Assalamu alaikum and good morning, everyone. So let us begin our class for today. I'm audible, right?
Yes, sir.
Okay, thank you. Let me start the recording. Okay, and is the slide visible?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so let us begin. Our today's topic is formatted input output, or in other words, we will learn about how actually printf and scanf behaves. So these are the topics for today that will be covered. So before going into formal studies, let's first learn what is formatting and templates. What formatting and templates are. So think of a restaurant or a super shop like Agora or Shopno, which are very common super shops in Bangladesh. When you buy any products from these shops, you will get a receipt. For now, let's say you're buying some products from Agora. Now today you're buying let's say some rice and oil, and the next day you're buying some shampoos and soaps and some other things. The receipts of the 2 days will contain different things, but the receipts have a similar format. Like it will always contain the logo of the shop on top, then maybe the address, the name of the customer, maybe his or her phone number or some kind of ID. Then it will contain the name of all the products, their quantity, and how much each of the product costs. And at the end of the list, you'll have total price to pay, how much you have paid, and how much you will get in return. So the structure is similar, though the values will change. That means some of the values will change, but overall the receipts will look similar. The values are the placeholders there. So there is a template or there is a format there, and you change the placeholder values with the actual values there and to generate your original receipt. In the similar way, when you write application, it also has a formatting, and you change some content inside the application while keeping the formatting intact. So in short, that's how formatting works. In the similar way, it is very common in programming languages inside a computer to format a string. A string, for now, you can consider as a piece of text. Anything that comes between two quotation marks, like if I want to show you, anything that comes between quotation marks called a string. So why do we use the two quotation marks? Because if we do not enclose it within two quotation marks, the programming language does not know that whether this is a literal text that we want to use or whether this is a part of the commands of the program. So if you want to write something or keep something as a text inside a program, we need to write it as a string, and generally strings are written surrounded by two quotation marks. You can see. Formatted input basically means the user will be giving the input in some specifically mentioned formatting. Like if I want the user to give two numbers separated by a comma, so we can say it like the format is like x comma y, the user can input like 5 comma 10. So that's a formatted input. Similarly, a formatted output is a way of showing this thing to the screen of the computer in a formatted way. A value is this number. So this number is a placeholder. The is will always be printed as it is, and this number value will be changed by some numerical value. So the most commonly formatted IO functions are output. For output, it is printf. This is the signature. We'll discuss about it. And for input, it's scanf. And their definitions can be found in the stdio or standard input output.h standard library header. By including this header file, we can use these functions in our code like you have been using till now. Now, for formatted output or the printf function, it formats a string and shows it to your computer. Now, this is the signature, or this is how you need to write the printf function. First, there will be a format string, and there will be a couple of expressions. So what are these? Let us look at an example. Now, this is a printf function. This thing within the two quotation is the format string, and these are the expressions. 10, 100, and 12.5 are the expressions. If you break it down, This is the formatted string, and the expressions we can also call it as an argument in the sense of function. When we discuss the function, you will understand why we call it argument. Now, 112.5. These are the two expressions. So our formatted string, as you have seen, let me write something so that it is even more clear to you. So let us just take an integer a is equal to 10, and we can write the printf function like this. So we can write, we can write the printf function like this. Printf value is, so instead of printing just an integer, let us print this integer a, another floating point value, just another arbitrary percentage d, just another floating point value using %f, and finally let us print just another integer %d, and let us go to a new line %n. And now these things are called conversion specifications. These are the placeholders. This thing in my IDE, things that are in green within the two quotations are normal, ordinary characters. These will be printed as they are on the computer screen. Anything preceded by a % symbol is called a conversion specification or a format specifier. These things are placeholder. %d is a placeholder for an integer value. %f is a placeholder for a floating point value. And this is another placeholder for an integer value. And this \n, anything preceded by a backslash, is called an escape sequence. They perform some they perform some compiler specific tasks. In that case, when you write \n, it moves to a new line in the screen. Generally, it will be difficult to represent how you want to move to a new line. Maybe you need to call another function called new line. So rather than that, just by sticking this character in our string, we can command that I want you to move to a new line at this point. Now, for each of the conversion specifications, we need to pass some expression, or an expression that evaluates to a matching value of the conversion specification. So for integer, we can write a evaluates to 10. This expression is fine. For floating point, we do not need to just pass value. We can also pass expressions that evaluates to a value, like 12.5 plus 2.2. This is also fine. This can be evaluated to 14.7, and it is a float. This will be fine. And we can also directly pass values like 5. This will work. Now, if I compile and run this, this is now 10, 14.7, and 5. If you go back to the slides, these are the conversion specifications highlighted in orange, and the blue one is an escape sequence. So we can encounter three things: ordinary characters, they are printed as they are; the conversion specifications, they are placeholders and replaced by the values they represent; and finally some escape sequences that perform some compiler specific actions. And one more thing, it's important: compilers are not required to check whether the number of conversion specifications and the number of passed arguments or expressions match. It is up to the programmer or developer to ensure it. If you pass less arguments than necessary, what will happen? That generally the compiler will print out some garbage value, like, sorry, I forgot to save it. There you go, a garbage value. And if you pass more values than the conversion specifications, the last one, in this case, generally the compiler will just ignore the last one. Some compilers will give you warning, like if these two numbers, the numbers of conversion specifications and the number of passed values do not match, generally Clang raises a warning, not an error, that these do not match. So you should take some care into it. Like if I want to use Clang here. Okay, so there you go. That's the warning. That conversions, more percentage conversions than data arguments. So some compilers will help you, some compilers will not. Clang is a more helpful compiler in case of compiling things than GCC. It's designed for this purpose. That's what they promote. So you might be able to turn on some more extra warnings in GCC and find these things. Anyways, moving on. So yeah, make sure you check that these two things are properly matched. And also one more thing, it's not the compiler does not know whether the compiler does not track the conversion specification and the type of data that you pass. So it's up to you to make sure that both of them match. That means if you write %d for integer, you should pass an integer, and if you write %f for a float, you should pass a float. Otherwise, you might see values like all zeros or some garbage values, or it might also appear properly. It depends on the implementation. Now, we said that the conversion specifications are printed, the ordinary characters are printed as they are, and escape sequences perform some special operations like going to a new line. So let us deal with the conversion specifications or the placeholders. This is a simplified form of a conversion specifications. So in a conversion specification has two optional things and a mandatory things. The m, you can consider the .p altogether. M and .p takes some integer values, and the x is the later. X is mandatory. The value of x, you always need to put it, but m and .p are optional things. Also, it can start with the preceding minus. So both m and p are optional, and if p is dropped, then the leading .p is also dropped. So you can see, you can say that .p is by itself is an option. So example, %10.2f. So the here 10 is m is 10, p is 2, or point p is 0.2, and x is f. X is necessary to specify the type. 10f, m is 10, p is not mentioned here, and x is f, and 0.2f here optional option, m is dropped, and p is 2, x is f. So let us look at what each of these does. So instead of reading from here, I'll show it here. So m is similar for integer, there are also characters, and floats. So first, let us look at what m means. If I say nothing, like also, so just so that you people can understand, I'll put some ordinary characters like these things before %5d. These ordinary characters will be printed as they are. Why am I printing? If something changes in between these two, so that you can notice that thing, what has changed. Also, let's make the value of a like 5 so that we can understand. Now, if I write %5d, compile it, and run, you see that %5 is preceded by some blank spaces, like 4, and in total, the width is actually 5. So that m, the format is like this, %m.vx. So here, m is 5 and x is p. So %5 means the minimum width field, or the minimum field this placeholder will take is actually 5 characters. That's why there is 5 characters, and I want to print the value of a. A is 5, so it occupies one of the characters, and rest of the 4 characters are filled using blank spaces. If a was like 10, in that case, and it has already taken 2 characters, and first 3 are filled with blank spaces. Now, if I put a minus symbol before this 5, this is that optional minus. Now it is %-m.px. It means that I just want to right align it. I just want to left align it. Previously, it was right aligned. What is the meaning of right aligned? Inside these blank spaces, or this reserved 5 spaces, my number will take, or will be starting from the right side of this space. So it will start filling from the right side and gradually rise up. It is very common in case of numbers. And what left aligning means, let us see. It starts from the left side, 2 spaces, and then rest of the 3 spaces, in total 5 spaces. So that's what the minus symbol does. -1 starts from the left, and minus starts filling the number from the left, while if you do not put the minus, it will fill from the right side. Remember one thing, when we are using the value of m can be expanded. That means we have given like only 3 space, but our number requires like 4 or 5 space to be shown. In that case, m will be automatically expanded to 5 slots. like this. So here the 3 is ignored and it is expanded to 5 source. Okay, so we have taken a look at minus, we have taken a look at M. Now we'll take a look at what dot P does. Okay, and in this slide, the square boxes represent space. Now, yeah, the value of P is actually dependent on the value of X. So first, let us look at some common values of X. I think I have already shown you or told you in the previous classes what the common values of X does. So if you want to print integer, we use D. If you want to print float, we actually use F, or we can also use E. There's also another one, that is G. So what E does, it basically prints the whole float in a scientific notation. That means something into 10 to the power a number. Generally, the decimal value comes right after 1 digit, like 5.3 into 10 to the power 1, 10 to the power 2, 10 to the power 5. Like if A is a float value, with the value of like 55.2, and if I write %E instead of %F, and I print the float, it will be like this. See, 5.52, then a couple of zeros, E to the power 001. That means into 10, that is 55.2. So that's it. But let's go back to integers for a bit.
Sir, I don't understand the output. E to the power plus 001. Why is it like that?
Okay, so this is scientific output. Let's say this is 55.2, right? But I can also write it like 5.52 into 10 to the power. Let's say for now this is power symbol. Just consider it power symbol. 1. Is it correct? 5.52 into 10 to the power 1.
Yes.
That is 55.2. Like think of Avogadro's constant in chemistry, 6.623 into 10 to the power 23, right? It's been a long time I have said that. So that's represented that way. So some numbers, generally in scientific notations, are represented like that. So this E here represents into 10 to the power. So if you try to understand this, this says 5.520000. These zeros doesn't make any, doesn't increase the value or decrease it. It doesn't hold anything. 5.52 into 10 to the power 1. This is the meaning. Since we need to write in one line, 5.52 E means 10 to the power 1. Okay?
So if I want to do, write 10 to the power more than 3 digits, then what will happen?
Yeah. Let's say I put more 5s, right? And then try to print it. Okay, I have gone out of the capacity of float. Let's keep it simple. That's way. Right. %E and A. I haven't gone out of the capacity of float. Okay, you see, now it is 5.55555 into 10 to the power 6. Does it make sense?
Yes, sir, I got this.
1, 2, 3, 4, 5, 6. So yeah, 1, 2, 3, 4, 5, 6.
So when we are giving input, sir, why after 5555.2 we are using F, sir?
Okay. What's the difference between this and what's the difference between that, right?
Yes, sir.
Okay. So if you write this, it is fine. But generally, if we do not take a look at the left side, this only value is actually not a float, but a double. In C, for storing decimal decimal numbers, that means number with fractional values, there are actually 3 different data types. One is called float, there is another one called double, and there's another one called long double. So what's the difference between those? Double is more accurate after the precision point. That means computers are not infinitely accurate. So if I write a number like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, float will, I think it's 7 digits, I've forgotten. I need to take a look when I teach you about data types. So float will only keep the values intact properly after like 7 digits. Let's take a look at it. I'll print like all the 10 digits afterwards. You see, only the 6 digits, 0.012345. These are accurate. The rest of them are actually garbage values. But if I make it a double instead of a float, everything.
Sir, you have to change the format specifier.
No. %f is fine for both double and float while printing values. But while taking the input, you need to be careful to use %lf or capital F if you're using long double. While giving the output, it is fine. So 0.1, this is fine. Actual double will track up to like 15 points properly. So if I put more data there, I can write 0.15. I'll come to this part later into this class. So that's the difference. So what's the trade-off between using float and double? Double will consume double the memory of float in your computer, and it is a bit slower in calculation than float. And also there are some other operations which are optimized for floats. So let's just not go into there now. For now, so when we write the thing, if after some number, we're imposing that this is a float. For now, if you drop the f, it's fine. I will not cut any marks or anything like this, but this right side, this is actually an expression which is evaluated. So if you do not put the value f, this is actually a double. You see, this is indicated as a double. And first, this double is converted into float by truncating or by dropping off some of the values after the decimal point, and then this is put into this variable a. And if I write it like this, if, then this is inherently a float, and then this is assigned to a. You can write a small letter f or capital letter f. Those are both fine. And the scope will be even more clear when we talk about data types. So yeah, we were at discussing p. So let us just forget about float for now and get back to integers. So let's say I want to reserve 5 spaces. 5 spaces for this integer value. Remember, I'm reserving spaces, blank spaces, and those things will be printed as a space. But I want this number to be 3 digits. Okay, 3 digits, not spaces. I want this number to be 3 digits. So how can we write 10 using 3 digits so that the value does not change? We need to stick a 0 before 10. That means 010 or 010. In that way, the numeric value will not change, and we'll be representing it using 3 digits. Now, if this is what this value of p does for integer. Now, if you print it out, you see 010. If I want like 4 digits, it's fine. See? Question?
So can you repeat it?
Okay, so the first value m actually reserves spaces for this placeholder. So I'm reserving 5 space to write 10. If I reserve 5 spaces for writing 10, what will happen? 10 takes 2 space, or 2 slots, and rest of the first 3 slots will be filled using just space characters like this.
Yes, sir.
Okay, but now I want that I will reserve 5 slots, but I want 4 among them to be digits, not space. So if I want to write 10 using 4 digits, I need to write it like 001010, right?
Yes, sir.
So this is what this %p imposes in case of integer values. Say 0010. But the number of reserved space is 5. Reserved slots 1, 2, 3, 4, 5. Among them, 4 are digits, but my desired value is 10. And it is right aligned since there is no minus symbol preceding it. Is it clear?
Yes, sir. I've got it.
Okay, so now we are done with integers. Let us take a look at floating point value.
Sir, what happens if we put 5.6?
Yes, exactly. I wanted this question from you. So what will happen if we put the value? What will happen if the value of p is more than m, right? So let us just take a look what will happen. You see, I have told you M is expandable. Whenever it is needed, M will be expanded. So now, since I actually want 6 digits, but I want to reserve 5 slots, 6 digits cannot be represented in 5 slots, so it will just take 6 slots. Okay. So that's it. It will just be expanded. But generally, people do not do these kind of things. They do some previous calculations and understand. This type of reservation of space is done when you want to output something in a pretty way. Like if you want to represent a list or a table in your console, in that case, you need to reserve these spaces. And so generally, you have pretty good idea because you know how long a number can be, the maximum value. And so you reserve those amount of space, and also similarly you calculate how many zeros you need to put before that. So it will be fine. This scenario should not occur.
Sir, if we take it, input as integer, sir, and if we take percentage e, sir, will it show in exponential order?
No, you should first cast it to a float. So let's just do it. Percentage e. It might work, it might not work, but generally it should not. It doesn't work, I think. Yeah, it's just garbage value. But if I convert it to a float, yeah, now it is fine, right? This is something called typecasting. We'll also talk about typecasting later. That means I'm converting this integer to a float. Anyways, so if you want to use %e with an integer value, you need to convert it to a float first. Okay, so now that we are done with integers, let us now talk about what will .p do for float. 1.2f. Let's just work with f. Sm for e. So the value of m is same. I want to reserve 5 spaces, or let's say let's reserve more spaces, like 8 space. What will p do is basically how many digits I want to display after the decimal point. Let's say my number is like 2, 3, 4, 5, 6, but I want to display only after like up to 3 digits, and I do not want to show rest of the digits. What I can do is write something like that. %8.3f. And what will it do? It will reserve 8 spaces or 8 blank slots, and it will display the value of 1. Remember, the decimal point takes 1 slot. So what it should display is up to 3 digits after decimal point. This takes 3 slots, 1 decimal point, 4 slots, and another one, that is 5 slots. And then to fill rest of the 3 slots of the 8 slots, it will display 3 spaces. Let's see whether the output is correct. Matches or not. Okay, you see, 1, 2, 3, and 1, 2, 3, 4, 5. 3 plus 5 is 8, and I'm displaying only 3 values after the decimal point, and the values are automatically rounded off. So there was a 5. So if I cut this, if I just remove this part, it should become, according to the rule of mathematics, 1.235. But if I want to display 2 digits, it should show 1.23 after the decimal point. Okay, is this clear?
Sir, is there a way to print zeros in front of these decimal number instead of blank spaces?
So if you want to print 0 instead of zeros, okay, there's something called flag. You need to use that. That's a bit more complex thing, but you can do it. Very good. If I want to cover each and every option that is available with the stdio library, it will take a lot of time, and you will basically get them jumbled up inside your head. So instead of trying to cover everything, let us learn the basic, and at the end of the slide, I have provided a link to some documentations. If you go there, I'll show it to you. You can find a large table containing all the possible combinations. You can look it up there, or if you want to achieve something specific, you can always Google it. Let's say how to put zeros up to this character in front of a floating point number in C. If you search this in Google, you'll get your answer. Programmers and Google are best friends. So yeah, you need to learn how to Google. Anyways, so this will also be same for if you use E. Okay, that means I want to print 2 digits after the decimal point. There you go, 2 digits after the decimal point, and it has already taken up 8 spaces, so that's why it's completely filled. Okay, and actually this is the complete form of the conversion specification. That's why I have written oversimplified here. And you have talked about zeros before floating points. Yeah, there are ways. So it can have flags with precision size. All these are optional, and this is the type that that is mandatory. You must put it. You do not need to memorize this or learn about this. I will not put give anything from this slide in the examination or even in quizzes. Anyways, let's move on. And about the common types, we have seen like these things. Okay, G. What does G do? G do? G is also for float, but is for printing. That means among E and F, G will choose the one that is best and takes less space for printing the floating point number. It's commonly used with scientific numbers as well, since they can vary a lot. So putting them in a compact way is good for the reader. And anyways, there are also characters and strings. We will look at them later. So about escape sequences, we have seen \n already. It takes us to a new line. We can also write \t so that it puts a tab inside our printing. Like if I write a \t here, it will be shown with 4 tab spaces because in my OS it's 4 tab spaces by default. I think it is 4 or 8. It's 8 tab spaces by default. 4, 5, 6, 7, 8. Okay, 8. There are the 8 spaces. So try to play with these things, write your own. Like \, should make a ting noise in your computer, but in modern laptops it does not make any kind of noise, but in your PC it might make. It depends whether you have a browser or not. And \r is carriage return. So when I print something, the cursor is after printing is basically here, but if I write \r, it will automatically move back to the starting position of the line. We might use \r after sometimes, but I will give it to you like as a task or assignment so that you can figure it out what it actually does. Anyways, so right, \/ is used to define escape sequences. So if we actually want to write \, instead of a single \, we need to write double \. And since quotes are used to define strings, we need to write \/ quote to represent quote. One more thing, if you want to print %, on this one is different. Since percentage sign is used for conversion specification, we need to write double %. Double % will print a single percentage symbol. Anyways, if you ever forget any of this, just look it up.
So can you repeat the double percentage thing?
Okay. So since percentage is used to define a conversion specification, right? Whenever a percentage symbol is seen, the compiler thinks or C program thinks that okay, anything following after that should be a placeholder. So there is no way for you to print a percentage symbol normally, right? How would you know that you actually are not putting some placeholder value here for conversion specification? Rather, you're putting a % symbol. That's why, in order to print %, a single percentage symbol, you need to write double %. % after % means a single %.
Yes, sir, understood it.
So we are done with formatted output for now. Sorry, I'll be rushing a bit in today's class only because I need to make up some time for the times that I have missed in the beginning in order for me to cover at least the amount that is necessary for me. So now we will take a look at scanf for formatted input. We have taken a look at formatted output. Okay. So it's like the counterpart of printf. That means till now we have shown to the screen. Now we want to take the input from the user and actually parse it in a proper way. What is the meaning of parsing? There is a format. The user gives some input. I want to break down those inputs according to that format and store the values where necessary. Let's say we're representing a point. A point requires 2 values, right? A point requires 2 values. Let's say x and y. If I want to represent a point using x and y, I need to take the input of x and y from the user. Now, the most common format of writing a point is something like this, 10.5 or something separate. Basically, let's drop off the brackets. It's like a number followed by a comma, then followed by a number. So what I need to tell you, the compiler, that Okay, I'm expecting some input from the user separated by a comma. So we can write it like this. So I want a float, %f. I want a comma. I'm putting a space here because it has some meaning. We'll discuss about it, %f. And then where do I want to put these values? I want to put the first value in x. I want to put the second value in y. Now if I print out the value, now if you compile and run this, remember the program wants me to input two values separated by a comma. 12.2 separated by a comma, and let's say 2.3, and it prints out 12.2, 2.3. What will happen if I do not follow that? What will happen if I write 12.2, 2.3? Okay, it didn't work, right? The value of y was not taken. Somehow scanf stopped working after parsing just one input. So that's why following that one is necessary. That means I need to pass two values separate by a comma. So let's see how scanf works. This is the signature of scanf. That means it will also contain a format string, and after that some expression. However, the expression, let's say for now, it will be just ampersand sign and then some variable. Actually, okay, let's not. I will not just say that word. It will make you confused. Sorry. Let's just say the ampersand sign is very important. It basically tells that it's the address of the variable where to put the value. For now, that is enough for you, and there will be a variable afterwards. Okay, so yeah, I want to scan an integer and then a floating point value. So what I can do, I can write %t, %f, and then like var1, var2. And this will be absorbed in the var1 will be the first passed value will be absorbed in var1, and second passed value will be absorbed in var2. Like if the user inputs 10, 11.25, then 10 is stored in var1 and 25 in var2. And remember, the ampersand symbol is very necessary. If you are not sure what you are doing, then yeah, you're most probably missing an ampersand sign. So yeah, remember to put those. So it looks very similar to printf statement, but generally the conversion specifications are simpler. You remember there is a word called generally, so it can actually become quite complex, but let's not go there. Again, the format strings can also contain ordinary characters, conversion specifications, and again escape sequences. Now we'll take a look at what those do. But before that, again, compilers are not required to check the number of conversion specification matching with the number of arguments. Just like printf, number of conversion specifications inside the format string and the number of passed arguments, whether they are same or not, it is completely up to the programmer to ensure. Some compiler will help you. And also, generally %d is used for integers, and you can use like %f, %g, and %e. Everything for float. There is no difference between %f, g, and e. All of them will be like parsed as floating point. So also you can give your input as like 1.2 into 10 to the power 2, comma 2.34 into 10 to the power 1. If you add this, it's completely fine. The values are taken there. Though it is %f, it is behaving like %e. So in scanf, there is no difference between %e, %f, and %g. Okay. So scanf is basically a pattern matching systems. That is, what is pattern matching? It takes each of the input characters one after one, like first one, then dot, then 2, then e, then 2, then comma, so on, and then it tries to match with the specific pattern that I have asked it to match, and that pattern being this one. the format string. That means it tries to match the first thing with a floating point number, then it needs to look for a comma, and then it needs to match with another floating point number, and there is a space between it. So we can encounter a couple of things. Let's move on there later. Okay. It tries to locate an appropriate item, skipping blank spaces if necessary. This statement will be explained later. So what will happen if that pattern is not matched, like I have shown you before? So if it is matched, if it is successful, every value will be put where it is supposed to be, and then it will continue processing rest of the input. That means I want a floating point number, a comma, a floating point number. The first floating point number matches. Okay, it is satisfied. It is put in the value. It is put in X. Then it finds a comma. It is satisfied. It finds another floating point number. It puts it in Y. The statement, the line ends with a new line character. It knows that now it needs to terminate, and the scanf is completely happy. It has parsed both the values, and we are also happy since we're able to parse those values. But however, when I have inputted like this, 12.2, there is no comma in between. After parsing the value and putting it in X, scanf doesn't know what to do anymore because it couldn't see the comma. Instead, it found some numerical values. So it holds the execution there and saves the value 2.3 for later execution. Scanf actually maintains a buffer. What you input comes in the form of a long list. If you even input in like 5 or 6 or 10 lines, scanf sees it as one single buffer. It goes to the buffer one by one. So whenever it cannot match, it stops right there, and the next scanf call will resume right from there. So we'll take a look at an example. Also, when searching for the beginning of a number, scanf ignores white space characters. What does that mean? When I write %f, it will consider this thing, it will consider this thing, 12.2, and it will also consider something like this. A lot of spaces, maybe I enter a lot of spaces, 13.2, a lot, then let's just put a comma for now, a lot of spaces, another enter, a couple of more enters, a lot of spaces, some tabs, 12.3. Scanf is still fine with those because it is ignoring those white spaces. So what are white spaces? Space, tab, new line, there are some others. These things are called white spaces. Anything that puts some blank space in your input or code, those things are called white spaces. New line, tab, and space. So whenever scanf is looking for %f or %d, whatever it is, a number, it ignores any preceding white space. Okay. When searching for the beginning of a number, scanf ignores white space characters. Okay, now let us consider the call %d, %d, %s, %f. So what's the format that scanf is trying to match? It first needs to look for a integer number. To look for an integer number, it will skip any number of initial white spaces. Second, it will look for another integer number, skipping any number of white spaces. And then a float number, skipping any number of white spaces, another float number, skipping any number of white spaces. And they will put in ABCDE. Okay. So just for example, these are white space, or these are space, these are new line, and all of these are white space. If I give the input like this, scanf is still fine. It will ignore this, it will purge this. It will look at something like this. Look at it, something like this. This is the buffer. So here, all the white spaces are skipped. 1 is put in A, -20 is put in B, 9.3 is put in C, and -4.0 into 10 to the power 3 is put in D. Also, about the final, you people do not see the Google Meet is sharing a screen right here, right? Or is it visible to you as well?
It's visible.
Okay, okay, that is fine. So this is the last new line character here. So scanf actually picks at the final new line, but it does not read it. The buffer pauses there. It just at 3, just before the new line. And if you add something more, like 1, 2, 3, it will be added after this new line. And if you call scanf again, it will start from this new line. So if you are looking for another integer in the next scanf, since this is a new line, and scanf ignores any white space before a number, this will be skipped. This might seem a bit confusing or complex to you at first. So I would recommend you to keep using these things, try to mess with these things, and try to create as many mess ups as you can. But by doing so, you will gradually understand how a scanf actually behaves. So how does scanf matches some pattern? Well, if it is looking for an integer, So how do you commonly write an integer? 1, 2, 100, minus 100, plus 100. So first it looks for an optional plus or minus sign, then some digits, and read until no digit is found. Fine. How to read a float? It looks for some plus or minus in the beginning, then some digits. After that, there can be a decimal point, and if there is a decimal point, there can be some digits following it, like 1 minus 12.13, those digits. After those digits, I can write 10 to the power something. So there can be an optional e, and it can also be 10 to the power minus something to represent the floating point value. So there can be an optional minus sign or a plus sign or no sign at all. Then there can be some more digits, and yeah, that's it. So a floating point value can be like this. If I write this here, it can be minus 1, 2, 3, minus a sign, then some digits, then a decimal point, maybe some more digits. Just do it anyways. Then it can have e, small e or capital E, both are fine. So it can have e, then it can have a minus, it can have a plus, or it can have nothing. It is fine. Let's go for this plus now, and it can have some more digits. So those are fine. So if I'm looking for an integer, then I cannot have a decimal point afterwards. And if I'm looking for like some floating points or integers, I cannot have something like ABC afterwards, right? Because those are neither integer nor floating points. So if I encounter something like this, scanf will stop execution and stop right there and keep rest of the things in the buffer for later execution. It just put it back to read again using the next specification. So right, 1 minus 20.3 minus 1 minus 20.3, then minus 4.0 and I want to parse it using 2% D's and 2% F's. So what will happen? First, take a look at this. I want to match an integer. Is 1 an integer? Yeah, it is fine. So this is the first number. Next, I want to match another integer. Okay, minus, it can be part of an integer. Okay, it is matches. 2 can be part of an integer. 0 can be part of an integer. Can point be part of an integer? No. So it breaks there. So minus 20 goes into the second integer slot. Then it looks for a float. Can point be part of a float? Yes, it can. Can 3 be part of a float? Yes, it can. But there is no e symbol, so I cannot. So there cannot be a minus sign afterwards. So it breaks after that. And finally, it looks for another 4. Minus is fine. 4 is fine. Point is fine. 0, e is fine. 3. Okay. So this is how these 4 numbers will be separated using this format specifier in scanf. I might give you something like it in quiz or exams. So try to run as many scanf statements as you can by coming up with different ideas, and you might also take some help from the book. There are examples there. Anyways, so what happens with the white space characters, right? Why did I put a space here? So there can be like 3 scenarios. There can be format specifiers, and we have already seen what scanf does with the format specifier. There can be white spaces, and there can be non-white space characters. \n is another white space character. And for scanf, all kind of white space characters are exactly same. That means scanf treats space, \t, \n, sorry, all of them similarly. What happens when you put a white space character in a scanf? So what happens when it encounters a white space characters? It tries to match 0 or any number of white space characters that can come in between. So before going to what white space characters, first let us see what non-white space character does. If I had written it something like this, and also make it integer for now to make it easy. Okay. So now what this format specifier actually wants to match is a number or an integer. Let me write integer. Exactly after that, it wants to match a comma. It needs to find a comma exactly after that, and after that comma, it looks for another integer. Okay, so what will happen if I input 10, 20? First, I can also put as many spaces as I like before this 10. It is fine. As we know, the rule of parsing number is it will ignore any number of preceding white space. So for this 10, first it is looking for an integer. So this 10 will be parsed just right, and it will be put into X. Exactly after the parsing is over, the next thing it wants to find is a comma. So it finds a comma, it matches this comma, and it throws it away. It throws this comma away, and then it tries to match another integer number, that is this one. So it finds 20, it finds push 20 here, and it puts this value inside Y. So why did I put this space before this comma back then? If I do not put this space between it, and I give some input like this, 10 space comma 20, now it first matches the first integer, then it puts it in X. Now instead of finding the comma, it actually finds a space, and scanf doesn't know whether it should ignore this space or do something else with it, or whether it should match it. So as a result, scanf halts right there. It stops. We have parsed the value of X, but we haven't parsed the value of Y, and it keeps rest of the things like after this for the next call of scanf. Like if I call scanf right after this, to read from here. And also there's a backslash in afterwards if I press enter. So that's why scanf stops. So if I put a space before it, now scanf knows, okay, first I need to match a number, an integer. An integer can be preceded by any number of white spaces, and I can ignore all of those. After that, there is a space symbol. This orders scanf to ignore as many white spaces come after the first integer. It can be 0, it can be 1, it can be 100, 1000, anything like that. It will ignore all the spaces until it finds a comma. And when it finds that comma, it knows that, okay, this comma has matched. So now I can ignore this comma completely. I will discard it, and next I will match another integer. And for matching integer, we know the rule. This is a number, so we can also ignore any number of preceding white spaces. That's why we give this white space before this ordinary character. So this, you can think of each of the individual things inside a scanf as a command. %d commands it to parse an integer. And to parse an integer, since integer is a number, I will ignore any number of white spaces before that. This is inherently coded into scanf. Afterwards, I find a space. Finding the space means that I should ignore any number of white space that comes after the first integer. Then there is a comma. It means after ignoring all the white spaces that is possible, I must find a comma. It cannot be a number, it cannot be ABC, it cannot be a question mark, it cannot be anything else. It definitely needs to be a comma. If I find a comma, then I am satisfied. This comma is ejected, and then I need to look for another integer. So again, my search for number begins. I can ignore any number of initial white spaces, and then I need to find another number and then put it with inside Y. Afterwards, I'll find a backslash n. Since I have hit enter in my keyboard, I will take a peek at it. I'm done with the parsing. I'll keep the backslash n for the next call of scanf, and I'm fine with it. So that's how scanf works. Another common example, if I want to parse some fraction. So to represent a fraction, we generally write it like this: A by B. Like to represent 0.5, we like fractions like 1/2. So instead of like asking for 2 integers from the user, we can ask the user to input it like this. Again, that an integer, then space to ignore any number of white spaces. It can also be backslash n. It means the same thing. It can be backslash t. So since a space looks better, we generally just use a space in scanf. Then it must find a forward slash, and then it can also ignore any number of white spaces before this integer until it finds it. So that's how we work with scanf. So if I run this, I input 10/20. So yeah, it's 10/20. But if I use spaces 10 forward slash, it's fine. But hadn't I put this space here, and if I run it, okay, 10, I put some space, put a forward slash, then put 20. The 20 didn't work, the 10 worked. Why? Because I didn't tell it to skip the white spaces. But if I write 10, instantly after that a forward slash, maybe some space, then 20, it will work. So that's why you need to put the space here. Be careful, very careful about using ordinary characters. Yes, any questions?
Sir, if I, while giving input, sir, like %d, if I don't give space, sir, and also while giving input, like I don't give any space, sir.
Okay,
Then-
so you do not put any space here, right? And you also do not put any space in the input. That's what you said.
Yes, sir. Yes,
Yeah.
sir.
In that case, it will work fine. Why? Because after 10, it needs to immediately find a forward slash symbol, right? And you are satisfying that need. You are giving that forward slash symbol right afterwards. So scanf is happy. It will parse that forward slash and parse that 20, and it will work just fine. But this is even more universal. That means it can eject any number of white spaces, and any number includes 0 as well.
Yes, sir.
So,
Got it, sir.
so this is more robust for parsing the input.
Sir, so as we have seen, all the white characters are same for scanf. Is it also true for the non-white characters? Like, can I divide the inputs with full stop instead of comma?
No, if you write, I mean, non-white space characters are matched as exactly as they are. If I put full stop here and then compile it, you need to put full stop before the number. You need to write like 10.20.
Oh,
Very
okay.
close to 10.20.
Okay.
But if I write 10/20, slash will make conflict with the dot, and scanf will stop parsing there.
Okay.
Okay. So non-white white space characters are matched exactly as they are. Anyways, okay. So yeah, non-white
So-
space characters. Yes.
Sir, there y, the value of y is changing every now and then. Yes, first it was a random value, then another random value.
Okay.
How
So
this random value comes?
how does it work? When you define an integer, okay, so it is linked to memory. So when we store something, it is stored in our memory, and the memory in our machines are our RAMs, right? We have RAM in our random access memory. We have RAM in our computer. So when I try to declare these variables, our space is reserved in the memory for these variables. However, the space is reserved. The space is not cleaned. So any previous value that had been there actually is still there until I overwrite it. So when I execute it and the value of y cannot be parsed, I can see that previous garbage value. Okay, this is that garbage value. So
Okay, sir, I've got it.
there's something called optimization, and some optimizers actually make sure that when you initialize a value, it is turned to 0, but do not rely on those. Be specific about in your codes. If you want to initialize something with 0, be verbose, be clear, and initialize it with 0. Only in those cases. Now, if I do something like this, and if I compile and run, and I put something like 10.20, second value should not be parsed. So yeah, S10, and since I have initialized it with 0, it is 0. So we generally drop it when we are pretty sure that, okay, we will not be dealing with a garbage value. There are ways to catch if a scanf fails, but that's some advanced topic. So let's forget about this for now. But in real life scenario, we catch whether something is successful or not. Actually, in real life, we do not use scanf in large scale applications. Pattern matching has some pain, and there are some more powerful things. Scanf is only available like in C. I haven't seen any other language that actually matches pattern with the built-in or with the standard library input function. There are some other powerful things like regular expressions, which you should run in like 3rd year or 4th year. That thing is even more powerful. I think you can still use a scanf, regular expressions with scanf, but that will become a lot more complex. So forget about it. Be simple for now as a beginner's course. Anyways, okay, example of match I have shown you already. So some common mistakes with scanf and printf functions. First, Okay, remember, you need to use ampersand sign in the scanf function in most cases when dealing with variables, but do not use ampersand signs in the printf. Otherwise, it will print garbage value. It will actually print the memory address. Okay, but so you do not want this. So forget about this ampersand symbol in printf. Do not put it there. Just write the actual value. And yes, like I have told you, ordinary characters, be sure how they actually behave and only then put it inside a scanf. And if you're writing an application, maybe when you're dealing with a project, remember, if your input is specifically formatted like this, that means it wants a number, then maybe comma and then another number, be sure to give an example that, okay, your input should be exactly like this, using a printf scanf statement before your scanf. And finally, do not put white space characters at the end of your scanf statement. It can be \n or it can be space. Why? Because if it happens, it will not register the enter key. I mean, it will register. What will happen if I write something like this, and if I compile it, and if I run it, now let's say I've put 10, a lot of spaces, and then 20. I press enter. Okay, why isn't the input terminating? What's happening? So what is actually happening? If you do not put the white space here, scanf knows that after I find the last integer or last number, if something else appears other than something that can be part of a number, it needs to hold the execution there and keep the remaining things for the next execution of a scanf. But if I have put a white space there, it can be space a \n or \t. Now it knows that, okay, after the last integer, I have a space. It commands me to discard as many white spaces come after that. So now if I hit enter, it will actually consuming all those white spaces. In order to stop this, I need to enter something that is not a space. I can enter 1, I can enter question mark, I can enter ABC. Anything that is not a space will terminate this scanf. But since I have given this white space at the end, it is now consuming the inputs and keeping me on a loop. So it can make interactive applications hang. So be careful about these scenarios. Okay, that's all for today regarding scanf and printf. So before I take a question, let me show you some documentation. So like this is the documentation for scanf of CPP reference. There is a beautiful table. It shows what each of the conversion specifiers does, and as I've said, there are like 3 data types: float, double, and long double. So if I want to scan long double, I need to put a large L before F, like here, long double, or small L for double. So you can consult this table if you want to parse any specific kind of data type, and if you want to find something even more specific, like how to print zeros before float in C, you can search it in Google, and yeah, there is your answer. You can do zero padding before the decimal point. If for not forgetting printf, like %0.4.fd, like these things. For extra leading zeros when so you can go to this Stack Overflow. Since you are a beginner and doing coding for the first time, that's what I'm assuming. So yeah, that's why I'm teaching you how to Google. Afterwards, I will not show you how to Google anymore. It's up to you to learn how to Google. So yeah, you'll find your answers. So be efficient in searching your answers. Anyways, you can read chapter 3 from C Programming, a Modern Approach. That's an easy book. So you will find even more insight about scanf. So any question? Yeah, sure. Yes, I mean if you want to scan 2 integers, remember the rule for parsing numbers. Integer is a number, and while looking for a number, it will ignore any number of preceding new lines, right? So if I write %d, what this application will do, if I execute it, you want something like this: 10, new line, 20, right? Okay, so this will match with this one. Why? Because first 10 will be consumed by this percentage D and it will be put in X, right? And then it is looking for another number, but the number can be preceded by any number of space or white spaces, right? And new line is a white space, so it's fine. And after that it finds the 20, it is consumed. I press enter, and there you go. Okay, then you cannot do it with single scanf. You need to do it with two. Okay, so you need to do it with two scanf. Two lines, yes. Yeah, one scanf like this, and it will only have %X, and the next one will contain only %Y. Okay. So I will just give you two recommendations. If you're into like problem solving, competitive programming, or things like that, so those things require you to generally give the inputs in a single line or like separated by space, white spaces. So in those cases, you generally need one single scanf statement generally. So that's the thing. But if you're designing a project or an interactive application for a user, remember it's always better to take inputs one by one and ask the user with a printf, like input one number now, then you ask the user for input, you input it. Like you have seen the first application that I have provided you, right? The one that was your very first assignment, where I asked you to compile that program, run it, and give your information, right?
Yes, sir. Yes, sir.
So if I asked you, like, give your full name, give your nickname, give your email address, each and everything separated by a semicolon in a single line, for a user, it would have looked really, really ugly, right?
Yes, sir.
Okay, so that's why in those kind of scenario, there are like two scenarios. One is like competitive programming and problem solving. Those requires one kind of use of scanf, and like a real life scenario where you are dealing with the user in command line, those requires a different kind of processing. So first you need to understand who are your target audiences, who are your users, and based on that, design your input system. Okay. Any more questions? Okay, if there is no more question, okay, sir. Sorry, Bernio, if I was speaking too fast, I'm really sorry. So let me know by your voice. I do not always get to see the chat. And today's lecture was a bit long, and as I've already said that I had to finish it in time to cover up enough for your syllabus, so I might have spoken too fast, so I'm really sorry for that. What you can do that I will afterward upload this video, and you can watch this at like 0.75 speed, and if you face any problem understanding any topic, you can always like mail me or ask me in the next class that answer I haven't understood this thing in the previous class, and I will try my best to explain to you. Okay, then I think you people have a really hectic day today, a busy day. It's Thursday, right?
Yes, sir.
So yeah, generally Thursdays for everyone is really busy in IoT except the teachers, I think. So even some teachers have a lot of classes in Thursday, but for students, yeah, when I was a student, I also had to do a lot of classes in Thursday, and it was really painful. So anyways, best of luck for rest of the classes. Enjoy your lunch, and inshallah I'll see you in the next week. I'll upload this lecture and slides in the classroom.
Okay, sir.
Thank you, everyone.
Assalamu alaikum.
Wa alaikum assalam. Arsalan.
Assalamualaikum, sir.
Wa alaikum assalam. How is your progress? You said you have installed code blocks, so have you like coded any program and tried to run it?
Yes, I do it as I send you, sir. Haven't you seen?
Okay, you have sent me something? You have submitted your tasks, right?
Yeah, I have submitted, sir. But here I have a problem, sir. In UDoc you have terminology, etc. At the end, but I don't have that. When I run a program, so I got that.
I'm not using code blocks. Code blocks is for you guys because it is easy for the beginners. Okay, so the terminal that I'm using is called VS Code, and it's actually a bit as advanced setup that I'm using. But for now, if your code block works, first learn how to code, learn how to run those things, and once you are like fine with those, then I can also show all of you that how you can configure your own like VS Code or some other things so that you can run them. But for now, make sure they run. And also, I haven't checked the classroom assignments because I cannot check them every day, right? I need to prepare for these classes. I need to make your questions and things like that. So in my weekend, I will check those assignments. Okay.
Yes, sir. Actually, I'm working on CC programming, so I can understand easily now. It's not difficult for me. So,
Very well.
and I work hard for it, but this is only the.
This is only the beginning. So keep on following the lectures. So inshallah, follow the next lab. It will eventually introduce more topics and more things, and from there we'll try to like learn as much as we can.
Yes, sir. Yeah. And under your supervision, yeah, I can do my best, inshallah.
Inshallah, thanks a lot. Jazakallah.
Okay, sir. Assalamu alaikum, sir.
I will end the meeting now. And all of you are present today since I didn't get time to take the attendance.